Our next session, Jesse, I think I'm going to take a quick break, and we're going to bring in a couple people to talk about OpenTelemetry. So Jaromir, thanks for joining us.
Thank you. Thanks for having me.
Yeah, we'll see you around. And let's pull in Aulita and Eric, I think are the two.
Yep.
Sweet.
There's Eric and Alalita.
Oh,
Hello.
no, green screen.
Oh, no. You disappeared. You're back. All right. Justin's going to take a break. Thanks, Justin, for everything. And we're going to hang out and talk about OpenTelemetry, which is super exciting. I have been following this project since people were initially talking about it, and we are super involved. Alalita's team has been doing a lot of work in this space, so we want to give you this full half-hour session to talk about it, get people excited about it, see if we have some questions. First off, why don't you introduce yourselves? Alalita?
Yeah, hi everyone. This is Alalita Sharma, and I'm a principal technologist focused on open source observability. I work closely with the container teams, and we have been deeply involved in a lot of the key projects upstream on including OpenTelemetry, which we're going to deep dive into what we've been doing on it. And then also talk a bit about Prometheus, Cortex, Grafana, and other open source projects, FluentBit, that we've been involved with. And again, feel free to ask questions in the chat as we go through a really cool demo of the integration with EKS, where we are pulling in a lot of the metrics and traces for you to be able to observe your applications and understand the behavior. That said, Eric, would you like to introduce yourself very quickly, and then we can get started?
Yeah. Hi, everyone. My name is Eric Xue. I am a software engineer on the Adot team working under Alalita, and I've been working for just a little bit over a month now, but I also happened to intern under Alalita last summer. So glad to be back, glad to be working on OpenTelemetry, and excited to show you guys this demo that we have coming up.
Cool. So what I'll do is I'll just share my screen and get started with our talks. I'm going to cover a bit about what we are doing at a high level, and let's see.
Oh, Alalita, you're going to share your screen. Yes. Okay. So Eric will unshare yours for a second. Yes. No problem.
Sorry about that.
All right, cool. I'm going to share my window, and hopefully you can see it.
There you go.
All right.
Yes, we can.
Okay. So again, wanted to kind of dive into all the cool things you're doing with observability in OpenTelemetry. And for those of you who are not very familiar with the field but are interested in learning about it, monitoring on for applications and services has been around for a long time, and systems especially. You remember the days of Unix monitoring, where we did a lot with Nagios and other tools. And so fast forward into the cloud computing world, we look at monitoring and observability at a larger, in a larger way, because what we are doing is that observability is enabling you to understand the overall behavior of a system, right? It's not only your application, but it's also the infrastructure, it's also the containers you're working with, it's the clusters you're working with, and the network stack, the OS, everything, right? And observability enables you to track the dynamic states of the system, taking into account uncertainty and variation in behavior, and really understanding a better, ongoing view of what's happening overall in the system, and how can you actually leverage that information well to be able to provision your systems better, to be able to optimize performance and other aspects. So especially in the container space, observability in Kubernetes is something we are going to be diving into today. And Kubernetes developers, as many of you may be already, need to understand the telemetry data they're getting from their applications as well as from the infrastructure, get a better understanding of the code that you're running during runtime, and really, gathering more data enhances you to be more effective, right? It's common sense. But that said, again, there are specific types of data that we collect from the infrastructure as well as applications, such as metrics, logs, and traces, which are the three pillars, if you will, of observability data to be able to monitor applications and infrastructure, right? So OpenTelemetry is a great solution for observability in Kubernetes. It's used very commonly with not only with Kubernetes clusters to monitor and observe them, but also with your applications and with Prometheus metrics, StatsD, FluentBit, different types of data flowing into OpenTelemetry as a collection agent. So for those of you who don't know a lot about OpenTelemetry, it's actually the second most popular project in the Linux Foundation CNCF world. What it does is the project provides an open source collector agent, 11 language libraries, and a data protocol, which is the OpenTelemetry protocol for providing a standard specification to unify monitoring, managing, and debugging of applications and services. And that's super interesting because, here you're seeing, an open source project not only providing software components, but also actually providing a standard which is aligned again with W3C's distributed tracing spec and other standards, and unifying that as an industry standard to be able to interoperate across different platforms as well as different components that are being used to monitor the behavior of your applications. So OpenTelemetry, has a lot of promise that it brings to users. And it really has, been able to grab the mind share of a lot of different end users, customers, developers who are using it and building it as one collection agent to support all types of telemetry data, providing interoperability using a standard protocol, the OpenTelemetry data protocol, the choice of being able to access different sources, whether that's, compute services or whether that's compute platforms like EC2, and also being able to, instrument your applications to be able to monitor them and then send that data to the monitoring framework that you use as a destination. So the great power of OpenTelemetry is that you can instrument once and be able to deploy everywhere, right? You can use the single collection agent to be able to talk to your applications as well as to your infrastructure and be able to pull all that telemetry data and be able to, observe it on the back end of it. It's vendor neutral, it's open source, and a lot of users are looking at it and evaluating and using it in production. AWS, as we got involved 2 years ago, has been committed to the success of OpenTelemetry. And I'd like to talk a little bit about, what we are doing before we dive into the demos. So let me introduce, AWS Distro for OpenTelemetry, which is a secure production-ready, AWS-supported open source distribution of the OpenTelemetry project. And why this is interesting is because as a project, we have actually been contributing source code, contributing, improvements and changes on the project upstream 100%. And that's fundamentally a great, win-win, because I really look at it as, the source code being developed as a community in general with the industry, with different stakeholders, really building out the best solution and a really, really robust collection agent. And at the same time, being able to provide strong AWS guarantees downstream in a distribution, which is security reviewed, which is performance tested, production ready for large scale usage, and also being able to take a distribution and bundle that with what customers need, and can easily integrate and talk to any of the AWS observability services too. So Adot provides users the ability to instrument your applications to collect observability data, and of course collecting metrics, logs, and traces on EKS, for EKS on EC2, for ECS itself, for EC2 if you're running self-managed clusters, AWS Fargate with ECS and EKS, AWS Lambda, and on-prem, right? So you have such a variety of choices to be able to really use any kind of compute, and at the same time run your applications and be able to just instrument them out of the box, collect metrics, traces, logs, and be able to send it. And AWS Distro really, it makes it easier for you to be able to do that. I just want to highlight, some of the areas that we've been really excited to work on the OpenTelemetry project on. Super excited to be one of, some of the, having made a lot of cool contributions and adding a lot of really useful functionality for end users, and contributing to not only making core components on the project very stable, such as, again, reinforcing and making the collector core features stable, redesigning the metrics processor, converting some of the open census hooks that have been inherited in OpenTelemetry to the OpenTelemetry protocol natively, improving the release tooling of the project, adding to the configuration options that you can have, and the diversity of that on the CLI, ensuring that the Prometheus interoperability for the project is a first-class citizen, and enabling those changes to be built into the collector core as well as all parts of the SDKs, enhancing metric support in the language libraries, as well as enabling full compliance for the Prometheus remote write exporter, which is used for backends such as the managed service for Prometheus we have, and any other kind of distributed managed service that may be used in the Prometheus world. Similarly, enhancing stateful set support for being able to actually scale the collector and be able to use it in a Kubernetes environment, whether that's self-managed or whether that's a managed service. Adding tracing support not only for X-ray, but also for all the compute, centralized sampling. So you can see we've been doing a lot, and also participating in driving some of the key initiatives around eBPF profiling, and collection of eBPF data, RUM, which is real user monitoring. So this is super interesting because here you're seeing like an intersection with IoT and mobile end user devices, being able to collect that data also with OpenTelemetry. And here it's not only server side or service side, but also client side data that's being collected. Similarly, actually improving the instrumentation of OpenTelemetry, making it much easier to use and instrument and run with for end users, as well as sampling. So just wanted to kind of give you an overview of all the areas we're involved in. Obviously, we love to work on the project and are looking forward to doing a lot more. Just very briefly, before we dive into our super cool demo that Eric will be doing, what's next in OpenTelemetry? As many of you who may be following the project know that one of the key goals that the project has had over the last year has been to deliver metric stability and to deliver trace stability. So tracing was the first signal that the project stabilized, which means that the specification, the protocol, the API, the SDK, the collector, these are all stable for using tracing end to end. And you should be able to collect traces, from an application and easily pipe it to any monitoring backend of your choice. And similarly, now we are focused on metrics, right? So metric stability is the next big milestone. And here you can see there are several milestones I've outlined, which are being worked on actively right now. And we intend to complete stability requirements by the end of this year. You can see that Prometheus interoperability is a very key milestone for us on the project, enabling and ensuring that there's full interoperability for customers. They can use, if they're already using Prometheus data, then they should be able to easily collect that with OpenTelemetry and be able to reuse it. Similarly, making sure that the metrics APIs and SDKs are stable. These are the first 5 languages that are targeted by the project. So, expect to see rolling releases for these as in the next few weeks. And also, building out auto instrumentation, which means that instrumentation today is available in Java, and also building that out for JavaScript, Python, .NET, Go. So really, you can see stepwise, stability moving into not only the protocol and data model, but also in the API SDKs, as well as the collector. And then last but not least, after that, we're going to be tackling logs as the next signal for stability. And a lot is happening around logs. So the spec, OTLP, API, and SDK, a lot, right? So that said, I think that was kind of where I wanted to stop and switch over.
I'm going to stop.
demo.
I'm going to stop you for a second.
All right.
I just want to point out, like you just powered through it, and it was just so good. It was very complete, but I feel like you were so smooth. We could easily miss the impact of everything you're talking about here. 3 years ago, we were all chasing different solutions. And trust me, I love some of those solutions. We were chasing something for tracing, something for metrics, something for logs. Sometimes people were doing different things. You got the Zipkins, you got the Jaegers, and all of that stuff was good. And you'd bash script and duct taped it together, and you made it work, and it was great. In 2 years, we got into a place where there's this open source, agnostic standard, which comes with this open source project, which provides multiple languages of libraries. And we're there from the beginning, or from the last couple of years. Yes. We now have this distribution, which makes it easy for our customers to pick it up and just use it.
Totally.
And you've done all this work to make it just work on AWS seamlessly, but it doesn't have to work on AWS. It can work anywhere.
Yes.
That's basically, that's just awesome. And it might be the end of a 7-hour day for me, or it might just really be thrilled. I don't know, but I'm so excited about that. And I've been playing with it. Of course, I've been working with it, but I want people to understand, it's such a huge impact for the community. I think it's one of these projects that's just again, I'm waxing poetic, the beauty of open source, right? Where multiple people get together and say, we have to solve this problem. Let's get in a room and solve this problem. And yes. You're actively solving the problem. I love it.
Yes. And, it's the really wonderful thing is that we've all worked together, as not only collaborators in the community, but really some of the best, engineering minds coming together, solving solutions, putting together solutions at scale, right. Solving some of those challenges, and it's all open source, which really is a win-win for Fantastic. All users, right? So it's really an exciting project to be involved in.
That's great. All right, so I interrupted your segue to demo. I'll be quiet now because I want to see it too.
Yeah, absolutely. And this is a super cool demo. Again, this is all available, in the OpenTelemetry repositories already. We are going to talk about, how you can monitor and observe your EKS infrastructure and applications with using OpenTelemetry, specifically the OpenTelemetry collector, as well as with a Helm chart and an operator which we have enhanced so that, you can just configure and run with it. And Eric's going to dive into, walking through some of the architecture that we have. Eric, did you want to go through the slides first?
Yeah, Jesse, if you could actually switch back to the slides, I just have a couple that I want to walk through real quick before we get into the actual demo.
Okay.
Thank you for that. So before we get into the actual demo, there's a couple like components I want to talk about regarding the demo, and the first is the operator that Alita mentioned. And so what the OpenTelemetry operator is a implementation of a Kubernetes operator. And what a Kubernetes operator is a method of packaging, deploying, and managing a Kubernetes native application. And it also introduces new object types through custom resource definitions, or CRDs for short. And so in our case, the CRD is the OpenTelemetry collector. And so you can kind of think of the operator as a controller for our collector here. And for a quick breakdown on the workflow that this diagram is showing, we can see in the middle that the operator is essentially watching for the collector. It's aware of its existence. And whenever a user wants to create or update or delete a collector, the Kubernetes API server will notify the operator. And what the operator does is it first ensures that the required connections are available. And then after that, it will configure the collector in the way that the user describes. Next slide, please. And then I'll briefly talk about Helm and what Helm is. So like what Homebrew is for Macs, Helm is for Kubernetes. That is that Helm is the package manager for Kubernetes. And for the context of our demo, we're going to be using our OpenTelemetry operator Helm chart. And it's pretty straightforward to use. When a user wants to use our operator, they would tell Helm, hey, I want to download this Helm chart and deploy it in my cluster. And then Helm will take care of the rest. So it's pretty straightforward, pretty simple, and I'll show you what that looks like later on. Next slide, please. And then lastly, before we get into the demo, there is the end-to-end data path that I'd like to talk about a little. So I'll just describe it in short detail. So first, you're going to want to install your OpenTelemetry operator through Helm. After the operator is ready, we want to configure our collector. And here, when we're configuring the collector, just to note that there are 4 different modes to deploy the collector in. There is a deployment, daemon set, stateful set, and a sidecar mode. And I'm not going to get too deep into the advantages of each, but just know that each mode does have its advantages and their best use case. For our demo, we'll be using the deployment mode, and this just gives us a little more control over the collector itself. And finally, the collector will scrape the traces or metrics based on our configuration, and it will ingest these traces or metrics and export them to whichever service you choose to. So in our case, we'll be exporting to our Managed Prometheus service, or AMP for short, and we'll also be exporting to CloudWatch and X-Ray. Next slide, please. And then to get into the demo itself, there's a bit of setup we need to do. I've already gone ahead and done some of it just because, in the interest of time. So for setup, of course, you need an EKS cluster. And you also need to set up your AMP and AMG, AMG being our Managed Grafana service. We need to set up those workspaces. And then we also need to install a Cert Manager. And what the Cert Manager is a certificate manager that the Kubernetes API server needs to communicate with the webhook component. And the webhook requires a TLS certificate that the API server is configured to trust. And this is also pretty straightforward. Again, I'll show you this later on in the demo. Lastly, we're going to need to install the OTEL operator Helm chart and the OpenTelemetry collector, like I previously mentioned. Quick note about the collector itself. The way it talks to our services is through a SIG-v4 process. And what this process is the process of adding authentication info to our AWS API requests that are sent by HTTP. And to do this, we'll need our access key ID and secret access keys. And again, later on in the demo, I'll show you where exactly this comes into play. And then lastly, not to get too repetitive, but just going over the data path again. So we have our metrics and traces that we are generating. our metrics and traces that we're generating. I'll be using a traffic generator and a sample application to do this. And then we'll send those traces and metrics to our collector, which is controlled by our operator. And then finally, we'll export the metrics and X-ray metrics and traces to AMP, CloudWatch, and X-ray. And so if we could switch screens now, thank you. So first, we're going to want to make sure we have our cluster. So I've gone ahead and done this already, but we can check that to make sure that we are in the right cluster.
Yeah, and just to address some of the questions that folks have, just to make sure everything, as Jesse said, is open source and available on the OpenTelemetry project. It can also be, all these components can also generically be used by in any Kubernetes environment. You can run your own cluster, you can have it self-managed, as well as, it is not a AWS solution specifically. It's actually a generic solution that you can use.
And Eric, just while we have a second, can you make your font a little bigger? I can read it, but just a little bigger. Yeah, that's great. Thank you so much.
Yeah, great.
Of course.
That's awesome.
Right. Okay, cool. So yeah, we're in our current cluster, and then we're going to want to install our Cert Manager. It'll look something just as simple as applying a configuration file. I've already gone ahead and done this, so we don't need to actually run it, but this is what it'll look like. And then we can also check just to make sure that everything's up and running. We can run this. And you'll see that we have our controller, our injector, and our webhook that are up and running. And then next, we're going to want to install our operator through our Helm chart. And so first, we're going to want to add the repo in through this command. And you can see that I've already done this. And we just want to update it just to make sure we have the most recent version. And then after that, we're going to want to actually install the operator itself. Okay, great. And then next, I'm just going to check that. Oops. Okay, I'm just going to check that my traffic generator and sample app are up and running. Important things to note here are that really all that's important here is that the sample app is configured to send its metrics and traces to an endpoint that the collector is configured to listen on. And moving over to the configurations for the collector specifically, I realize we're a little short on time, so I'll try to get through this with all the pertinent information. But you can see in this config section, we have our exporter, our receivers, processors, and exporters listed. Here we have our OTLP receiver that's listening on this endpoint that our sample app is configured to send metrics and traces to. We don't have any processors for our data currently. And for exporters, we have three different kinds. We have our remote write exporter, our X-ray exporter, and our EMF exporter. The first one being for AMP. And this endpoint is of note as this is the endpoint of our Prometheus workspace. So this is needed for our collector to send our metrics over. And then EMF is our CloudWatch exporter, just for clarification. And then there's also the service section here where we configure our pipelines and just detail them out. So you can see we have our traces pipeline and our metrics pipeline listed out here. Lastly, you might need to specify an image. Here we're using the collector contrib image instead of the collector core image because we are using some of the contrib components like the 3 different exporters I mentioned. And then lastly, touching back on the SIG-V4 authentication that I was talking about earlier, to get your access key ID and secret access keys configured, one way you can do that is through environment variables, and this is what it might look like. I currently don't have mine, obviously, but I will be using them for the actual collector itself. So let's apply the collector. It's up and running. And then let's hop into Prometheus real quick. So here we have the Prometheus workspace. You can see this remote write URL is the same as the one in the collector config. We also have our AMG workspace set up. Things to note here is that we need to enable our single sign-on so you can sign into the Grafana console. And we also have our data sources, which are attached. So we have AMP, CloudWatch, and X-Ray attached. For now, we're only going to focus on AMP though. And then if we just move over to our console, we can check our data sources. We'll just add AMP for now. Select our region, and then select the right data source. And so you can see it's been added. And then we can go over to our dashboard, create a new panel. This has been happening for some reason. I don't know why, but refreshing always works. And then here we can just query for different metrics. So say, for example, we can select queue size, outgoing HTTP call, and then in the last, okay, well, that is interesting. For some reason, it's not working right now, but as you can see, it looks like it did show up. Here we go. So you can see that our metrics are being ingested and shown in AMP. Currently, there's not much going on because I just started it, but that's what it should look like. And you can also see in CloudWatch, I made a quick little dashboard to show some of the metrics. This is also interesting that it's not showing up yet. But it should show up in CloudWatch, and traces should also be showing up in X-Ray as well. So you can see here, there's a list of traces that are showing up, and this is where they're coming from in the URL section. But that should be it for the demo. I think we'll hold off on questions. I'm not sure if we have time, but I'll pass it back off to Alita to close it out.
If you go into the CloudWatch dashboard, is it continuing to collect, or is it?
Yeah, it should be. I'm not sure what happened.
Okay, it's just running in the background.
Yeah, it is. I did this, like 30 minutes ago, and I wasn't having issues. So it's very, very interesting.
So what did you, but after that, what did you do to appease the demo gods? Like, did you do anything in particular?
I don't know. The demo gods are always, always praying for my downfall, looks like. So yeah, this has happened to me a couple of times, unfortunately, but for the most part, things are looking okay. Oh, here we go. See?
There we go.
Now things want to show up. You gotta give it a little time.
We did assume it worked. You did, you did great.
Yeah.
Little JavaScript between friends. That's fine. That's great. And I think the power here is that this is a unified spec eventually for stability for all three signals, across all these different languages, where we just don't have to chase all these different solutions anymore. And this is fantastic. And we can look here. We're sort of out of time, but we can look here and see if there's and Elalita, did you have anything to wrap up?
Yeah, I just wanted to I just had one slide to thank you, again, point folks to some links for some of the active, workshops that you could use. And these are really good workshops that we have built around, sample applications and really being able to, walk through an end-to-end pipeline. So please take a, screenshot of this, go try it out. Everything is open source. Everything can be run on-prem, self-managed, as well as, with AWS services. So there is no, it's fully interoperable. That's something that as an open source engineer, we all care about, making sure that every component that we're building is completely used open source, right? So again, please take a snapshot, go try these out. You can find me on Slack. Also, on the CNCF Slack, feel free to ping me if you have any questions. And all of us work very actively on different open source projects. So keep in touch. and also participate in more open source. But over
Good
to you,
advice.
Jesse.
Yeah, thank you so much. That was fantastic, and it was a great session for us to end with. I think we're going to have a quick wrap up and to sort of say thank you to everybody at the end of the day here. But thank you so much for this session. Really appreciate it. Eric and Alalita, thanks for your time.
Thank you so much. Really nice to participate. Bye, guys. Bye, folks.
Bye.
Thank you guys.